Hello friends, my name is D. Mangabhavani. I am first MPCS. My topic is piezoelectric method. First of all, we discuss piezoelectric method. This method is based on phenomena of inverse piezoelectric principle. In 1880, Jacques Curie and Pierre Curie discovered on unusual characteristics of such crystals when subjected to a mechanical force. These crystals are electrically polarized. This effect is called as piezoelectric effect. In this, the word piezo means press and squeeze, which is a Greek word physian. When mechanical stress applied to a such crystals along a such axis, that means mechanical axis, then a small amount of voltage electric axis is developed along to the other perpendicular axis. The crystals which are shows this effect are called as piezoelectric crystals. Example: quartz crystal. The converse of above effect is also explained as if a voltage generating crystals, that means piezoelectric crystals, are exposed to the electric field, then the length of the crystals charges according to of the field and also strength of the applied electric field. This principle is known as inverse piezoelectric field effect. By using this inverse piezoelectric principle, we have to produce ultrasonic waves of frequency range above 100 Hz as follow. For this, first we have to study about piezoelectric crystals. These crystals are six-sided prisms having pyramidal shaped ends. In these crystals, there are three types of axes. First one optic axis, second one electric axis, third one mechanical axis. First one optic axis. The axis which is passing through the perimeter corners of the crystal is called optic axis. Second one electric axis. The axis which is perpendicular to the z axis and passing through the opposite corners of the crystal is called electric. Third one mechanical axis. The axes which are perpendicular to the both axis and z axis and passing through the faces of the crystal is called mechanical axis. Now we discuss about experiment. Now the X-cut crystal is contact in a parallel to a variable capacitor C1. Here the grid circuit is protected by a grid resistors Rg and a grid capacitor Cg. The DC voltage applied for the circuit through RF choke. This RF choke provides radio frequency currents. Here Cb is a blocking capacitor or base. Capacitors which provides DC currents through the circuit LC, while by RF passing RF currents. Now the variable capacitor C1 is adjusted to the natural frequency of the crystal. Then the crystal is said to be vibrated. Due to resonance, the circuit will use high frequency sound waves, which are called as ultrasonic waves. In this circuit, by using quartz crystals, then we can get ultrasonic waves of frequency range is 100 kHz to 500 kHz. On the other hand, if we are using to terminal crystal, then we get the frequency range is 15k into 10 power 8 kHz. Result: the frequency of turned circuit LC circuit is F equal to 1 by 2 pi root over LC. Velocity of ultrasonic waves V is equal to root over y by rho. For quiz crystal Young's modules, y is equal to 7.9 into 10 power 10 n by m square. Density of the quiz crystal, rho is equal to 2650 kg by meter cube. Then the velocity of ultrasonic waves in the piezoelectric method, V is equal to root over 7.9 into 10 power 10 by 2650 is equal to 5450 meter by seconds. In piezoelectric method, advantages and disadvantages. Advantages: it is more efficient than magnetostriction method. Ultrasonic frequency as high as 5 into 10 power 8 Hz can be. The output of the oscillator is high. The generator is in the effective to temperature and humidity. And, and disadvantages: the cost of piezoelectric fuse plate is very high. It cutting and snapping is very complex.